So this example from last night's homework was one that's called an arithmetic sequence. Arithmetic sequences are sequences that have a common difference between each term. Or in this case, you're adding 0.8 to each one of them. Another example could be you could be subtracting 2 from each one of them and whatnot. If the difference between the numbers is always constant, it's called arithmetic, or they pronounce it arithmetic because it sounds more fancy. Fancier.
Arithmetic. Isn't it just arithmetic?
Yep.
It's nuclear.
It's like,
Oh, here's that. Wait. Yeah.
how else would you say?
Nuclear? I don't know. What's a Homer Simpson thing? Arithmetic has common difference. So when you have this common difference thing, what a lot of times people freak out about is that there will be some examples from time to time that have fractions. Use the fraction bar in your calculator and just set it up. I'm not taking the calculators away from you, so these things should be pretty straightforward. Now, what we do here for when we write out what's called the general rule for an arithmetic sequence is that we have this formula. The nth term in an arithmetic sequence is always going to be defined by the first term plus number that you're looking for minus 1 times the difference. The nth term is the first term plus n minus 1 times your common difference. So the nth, writing the rule for the nth term is what we do. So we're writing out the equation. If we know the first term and the common difference, we just write it out in terms of n. Now, like I mentioned this to a couple of you guys when we were working on it yesterday, is that 1.9, 2.7, 3.5, it's a linear equation. Arithmetic sequences are all just linear equations. It's y equals mx plus b. That's all these are. You're just writing out the equation in terms of it. So what was the first term here? 1.9. What's the common difference? 0.8. So the rule for the nth term here, well, I would distribute this backwards at 0.8 and minus 0.8. The rule then for the generic term here would have been 0.8 n plus 0.8. That would be my nth rule. Just by combining like terms. 1.9 minus 0.8, 19. That's 1.1, sorry. Math is hard. I accidentally wrote it 0.8. I was thinking. Yeah. So the rule, just like we wrote a second ago, was 1.1 plus 0.8. Now I'm just writing in terms of slope-intercept form. Where my y-intercept would have been 1.1, my slope is 0.8, up 4 over 5. Okay? 0.8 is the variable. So what we're able to do then is we're able to take these arithmetic sequences and tell whether or not a sequence is arithmetic. If it's arithmetic, the difference between each number is the same. So -3, 1, 5, 9, 13. The difference between all of those is 4. So if I wrote out the equation for that then, knowing that my first term is -3 and my common difference is 4, well, nth term, first term plus n minus 1, and fill in the blanks. You'll see me do this a lot with these style problems because it's just real quick algebra. I would normally just rewrite my distributive property just underneath here instead of using a full step of writing 4n minus 4. And then I just combine these right away. And then I get a final answer of an nth rule of 4 4n minus 7. Basically, you're writing the equation of 2 points, or writing the equation of a line given 2 points. Your points happen to be 1, -3, and something and something. It's exciting.
Yeah.
Okay. Is there a common difference between the next ones? 2, 5, 10, 17, 26.
You're adding all the odd numbers.
You are adding on, you could figure out the sequence,
Yeah, that's not, it's like
but you can't write out the rule though. It's like triangle, square, square, triangle, square, square, triangle.
Square. Square.
Circle.
All right, not bad. What's wrong, Fleming?
Never mind, I got it.
Okay,
Wait, so you just write no then? Just write no?
correct.
Cool. My favorite.
All right, let's try another one. Let's write the rule and then find the 20th term. So what we're doing here is we're going to write out the rule for the nth term. That's just, it's arithmetic sub n. Yeah, A is really weird, I know. N is also really weird, because, you know, nth term number in the sequence. Sorry to debunk your myth. Crushing soul since 1992.
How long is before or how long is it?
Well, if I was born in 92, I'd be really, really young. And if I've been teaching since 1992, I'd be getting ready to be done teaching. I'd be very, very happy. No. I've been crushing soul since not 2000, or 2005.
That's high school.
Yes. What is your first term?
25.
50. What is the common difference?
6.
Is it 6 or negative 6? It's negative 6, it's going down. So write out the rule. Your nth term, first term, n minus 1, difference. That's exactly what it is. So your nth rule would be negative 6 plus 6. So it's going to be negative 6n plus 56 would be your nth rule. So then to find the 20th term, they're saying, hey, the 20th term would be negative 6 times 20. That's all it is. It's a linear function. Put it together, you get negative 120 and 56 is negative 74, I think? No, negative 64. Okay? Again, it is a lot of plug and chug here. Now, one thing I want to show you, if you think about it, you've got 1, 2, 3 variables. I don't count this secondary n value because these two will always correspond. So if you know that the 20th term, that would be 20. Okay? So that means I can set up some sort of equations then, knowing 2 of them solve for the third. It happens a lot with this. Okay? It happens a lot. So we got a couple little manipulations to work with. For example, if I know that the 13th term in a sequence is 30, and the common difference is 3 halves, I can write out the rule. But again, it's just plug and play, really. It's just substitution. All right? So if you know that the 13th term in a sequence is 30, and the difference is 3 halves, write out the rule. Nth term, first term, n plus 1, or n minus 1, excuse me, times your difference. Well, I'm using the 13th term, and I want to show you guys how I write this. I'm saying the 13th term is 30, and that has to equal the first term plus 30 minus 1 times 3 halves.
Wait, can you go back one first? Like back one second? What did you say? Dylan, don't you just solve for A1?
Yeah, that's all you're doing.
Can you just not put like A13?
There's a reason why I do that. It'll help it a little bit. It's just so you know which ones go where. That's all. It's just that's really all it is. And Art, if you don't want to do it, that's fine. It does get, there's a little more of a complicated step to this in a little bit, but I'm just trying to build it in. That's all. So then it's just a matter of substitution and subtraction and stuff. Then I'll give you your first term. So use your calculator, you're gonna get 30, 30 is the first term plus 29 times 3 over 2, whatever that is. What do you get for your first term? Some number. Yes. My first term is negative 13.5, negative 13.5. Or they might write 27 over 2.
Yeah.
So, negative 27 over 2 plus n minus 1 times your difference of 3 halves. And just fill in the blanks. So does that give me a general rule of, I found my first term was that negative 27 over 2.
Yeah.
And I'm resubstituting that back in to write the rule for the nth term. So I put back my difference in. I'm just going to solve it for n, so that my nth rule be 3 halves n, oh sorry, minus 15, right? Yeah. And that would be the rule. It's just a lot of back and forth substitutions. Knowing what you're actually substituting for. Sometimes you have to solve 2 of them simultaneously.
If you go back for a second.
Sorry, let me get ahead of you.
Okay.
Got it?
Yeah.
Sometimes what happens though, you have 2 terms in the sequence, and you need to figure out the rule. Well, think about it this way. If you know 2 terms in the sequence, you would then have 2 equations that you could then identify to solve for one part. So there's 2 triangles. It bounces in the secondary quadrant. You got the, yeah. So you know that you have the 6th term is 10, which has to equal the first term plus n minus 1 times the difference. Guys, so that means you have 10 is your first term plus 6 minus 1 times d. You have the other one. You have the 21st term, which is also the first term, plus n minus 1. Is that right? I wrote 6 here by mistake. This was supposed to be, sorry about that. It's supposed to be 10 here. I'm sorry, I was thinking of a different problem. No, it was 6, I'm sorry. I wrote this one as I screwed up on it. What? Sorry about that. I was looking at it for a second, I was like, wait, I thought this was supposed to be clean. It should be clean, what did I screw up? Anyway, I accidentally wrote 55, not 21. So what's 21 minus 1? I have 2 equations, and I have 2 variables. I can use a matrix if I want. It's a system of equations. But you'll notice which one is already isolated? First term, isn't it? So if I wrote this out, just put the other one here. What do I do to eliminate the first term? Subtract. Yeah, subtract them. We're solving for both the first term and the common difference. But in this case here, I can eliminate the first term by using a system of equations. I can eliminate the first term by using the system of equations. And throw it back in, yeah. Okay. So 55 subtract 10 gets me 45 equals 15. What's my common difference? 3. So if my common difference is 3, my first term is going to be how much?
It's going to be,
So what you're trying to do here is you're trying to isolate by using a system of equations each part. Okay?
So the A, like the negative 5 equals A is your starting point?
Yep, it's your first term. A sub 1 is your first term. Common difference is 3. Write it out. They seem like they're really weird. They're really quick. Okay. It's just been a while since you've seen a system of equations. So what's that? Yeah. It is. This is really all it is. It's just, it is. It's a lot of it. So it's 3n minus 8.
we've been doing this in like chemistry for the past like month and a half. That's what I thought they were when I walked in, but then I'm just like, nah, you would never just copy fish on it.
Of course I would.
My dad has a chemistry class.
All right. So these are sequences. Let's look at series.
Wait, don't.
Waiting, not doing anything. We're just running late, that's all. I want to make sure I get this in.
If we don't, then we can just watch second hours.
Yeah.
Wait, I don't think I Oh, it's like solve for it. Yeah, it's just solve for it.
Oh, it's for just put in 40 for n. Once you get the nth rule, you can figure out anything. All right. So let's talk about series. If I want to find the sum of a series, a finite series of arithmetic, there's another formula. So the series is written out a little bit differently. To find the sum of a series of however many is always going to be however many you're trying to count up, first term plus the nth rule with that number over 2. The sum of a series. Now granted, you might have a series of just like 6 numbers, and it's kind of a pain to fill out the whole formula for 6 of them, but if you have to add up 30, you want to use the formula. Because it works out really quickly to figure out the parts.
What if we're too stubborn to use the formula?
Then you're fine, whatever.
Alright.
You'll get there. It just takes forever. Especially if I ask you to, count 180 of them.
I still just
Challenge accepted. All right. So let me show you how this works with an example. If I want to take the series 4, 7, 10, and so on and so on and so on. One of the things that it doesn't say that you want to do, that I will suggest that you do every time you're trying to write the sum of a series, is always write out the rule for the nth term first. The reason that I say that is because you have to write the rule out to get to here, and then at some point in time, you're going to have to figure out however many of them you're looking for. So you have to get to the nth rule anyway. So always start by writing the rule. So your nth term, first term, n minus 1, difference. What's the first term? What's the common difference? So your nth term, 4 plus n minus 1 times 3, 3n minus 3. So it's going to be 3n minus 1. Okay? That gives me my nth rule. I always start by doing that because I'm going to need that eventually anyway. All right? Using the formula then tells me to take, well, I need to find the sum of 30 of these. Yes, sir.
Wouldn't it be 3n plus 1?
Yes, thank you. I didn't catch that. Thank you. I should, yes, I know, but I thought I could handle 4 plus. I can't even do that.
Then
So,
why are you a math teacher? I think we
acting! Brilliant. How many of them are trying to add up? 30. So the sum of 30 of them will be 30 times first term. Nth term will be 3 times 30 plus 1 all over 2.
Oh, never mind.
Again, it's a lot of formula work. Okay? Yeah. Or think of it this way. What's half of 30? 15. So it's going to be 15 times, well, this is 90 plus 1, 91, plus 4, 95. So you have 15 times 95. What's the sum of 30 of them?
A number.
Whatever 15 times 95 is, which is going to end in a 5, so you're halfway there.
Wow.
What do you get? 15 times 95.
1,425.
1,400. So if you want to add up the first 30 of those in a sequence, or in that series, excuse me, you get 1425.
I would still be fine.
You wouldn't do it.
Ah.
No, that's the same. Just but I just.
Here's the weird part.
Oh no.
How many do you have to add up to equal 175?
Probably a certain number,
You're probably right.
and I bet it's gonna have a fraction in it.
Do you add fractional amount of numbers?
No,
Basically, this means how many terms do you have to add up to equal 175? No. Can you have decimal?
17.
Here's what happens.
That's my guess.
You're trying to figure out how many of these do you have to add up to equal 175, which then you have to do 175 will equal how many added up, first term plus the nth rule over 2. What's the nth rule? This is the reason why I said, hey, you're going to want to write that out anyway, because you're going to need it always in part D. In the second part, you're always going to need it. So write it out.
A1 tangent. I was like, what?
I'm going to move the divide by 2 right away, double 175. What do you get?
Math.
Math, good. Otherwise known as 350. It's going to be n times our first term, which was 4, plus our nth rule, which was 3n plus 1. Which means in the parentheses is now 3n plus 5, and I have to distribute the n.
How do you come back or something?
Yeah, buddy.
Everything comes down to factor.
This was all good.
It's the fundamental theorem of algebra. Anyway, do you have a calculator?
No.
Yes. Should you ever have to worry about factoring?
Yeah.
Go to your table and find the 0. Guys, can you please stay off the phone? It's really getting old. Put it in a pocket and stop doing it. It's all day, every flippin' day. Put it in the calculator to your y equals and look at the table for a positive 0. Because obviously you have what times what's going to be 3 times negative 350. You'll have a negative 0 and a positive 0.
Wait, so you just have to put in this calculator like as in y equals?
Yeah. Hit the table and find out where it equals 0.
I always kind of felt like
That's all that is. Y equals 3x squared plus 5x minus 350. Go to your table. Where do you get a 0? 10. What's your answer? 10. What's that?
Wow.
No, I didn't. I just saw all that work on the beginning part. Just kind of
She was right. N equals 10.
I try not to be too smug.
Oh,
So does it matter if you have to factor?
No.
Because am I going to take the calculator away from you?
No.
I hope not.
What's wrong, Hopworth?
No calculator.
Maybe on the test.
What is that telling you?
Is that telling us that N is 10?
It's telling you that you have to add up 10 of these numbers in the sequence to equal 175.
Because I remember you like the table for
Tables,
I know what exactly it was.
tables give you your zeros. It's telling you where your term created a zero. If my zero is at 10, my term was x minus 10. So if I factored this out, it would have been x minus 10 and 3x and something. 15, I think. 3x, 15, whatever. I don't know. Math is fine. So that one would have given me a negative 0. This one gives me my positive 0. And since I'm counting up how many terms you have to count up, I can't count negative terms. That's just silly. So we do it this way. This is about as goofy as this gets, but you have a calculator, so you should be happy. And sometimes you don't need to math because sometimes the number's so small, it could be like the first 5 of those, and you'll always overlook it because you think too hard.
That's why it's just easier to do it by hand every question.
Sometimes it is, sometimes it's not. What's that?
And
No.
then you can just laugh and you're writing down what anyone, if someone did all this stuff.
No, you guys never overthink anything, ever. Ever. In like a bazillion years.
That's a lot of homework. Oh my gosh.
16 to 26, it is literally write the term. And then there's just a handful of the rest of them out. A lot of them are rather quick. I think it's 46 through, or no, maybe about, I think it's 50 through 56. Those even ones there have that tool part where one of them you'll have to use the factory to find how many you have to add up. But for the most part, this one goes real quick. And trying to find out the pattern in some of these is so much easier than what it was yesterday. To be honest with you, the pattern stuff you guys were doing yesterday is the most difficult of the pattern stuff we do it all in chapter 1. Because there's no rhyme or reason for most of them. For the rest of these things, they're either going to be arithmetic or geometric. And if it's arithmetic, common difference. If it's geometric, it's common rate. Multiply or divide. Okay? Let me go from there. What was it about though? When did I tell you this? I know, but it was in regards to something. No, I really did that one.
Hey, what was everything
Show us a video.
in class?
It was a video about.
Go back to the beginning of the class.
Oh, what was it about now?